Hello everyone, welcome to 1045 Engineering to yet another video on Grind 75, a better blind 75 coding series. So let's dive directly into our today's problem. So today we are at our fourth problem out of the 75 total problems. Best time to buy and sell stock. Okay, problem statement is that we are given an array of prices where it is prices I is the price of a given stock on the ith day. We have to maximize our profit by buying it on one day and selling it on another day. We'll jump right into the question and we'll try to solve it in the time complexity of O of n. Let's go. So I'll just state it out again. Grind 75, again we are solving all the questions from Grind 75. This covers all the questions from easy, medium and then hard. If someone is well thorough with all the questions from this set, they are very well ready for their interviews and interview coding questions. Okay, so last time we have already solved problems on two-sum, we solved valid parentheses and merged two sorted lists as well. Today's problem is best time to buy and sell a stock. Okay, let's check. Okay, let's go through the problem statement once. You are given an array prices where prices I is the price of the given stock on ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Okay, firstly, one thing quick. If we are buying a stock on any of the day, it can only be sold in the future. So we can only move forward in our transactions. You must be aware of this from stock buying selling. If you buy it on a certain day, you cannot sell it on a previous day. You can only sell it in future. Let's understand the code example. Okay, so they have given this array 7 1 5 3 6 4. If we buy it on and the output is 5, buy on day 2, that is 1, and sell on day 5, that is 6, and we can make a max profit of 6 minus 1 equal to 5. Okay, so few things let's understand quickly is the problem looks tough, but it is actually easy. It is not that easy, but once you understand the logic, it is a really easy problem. Okay, let's say you buy a stock on the first day, which is 7. If you sell this stock on any other day, it's a loss, right? Because if you buy it on 7, even if you sell on 1, it's a loss of 6 rupees. If you buy on 7 and sell at 6, it's a loss of 1 rupee. If you buy at 1 rupee price and you sell it the next day at 5 rupees, it's a profit of 4 rupees, which is good profit. But is it the maximum profit? What if you buy it on at price 1, sell it for 3, it's a profit of 2 rupees. Similarly, if you buy it at 1, sell it at 6, it's a profit of 5 rupees. And similarly, when you sell it at 4, it's a profit of 3 rupees. What we have to do is we have to find out on which particular day can we buy this stock and which particular day can we sell it. Okay, go ahead, pause the video for some time and please think of an approach that you would take to solve the solution. Okay, there can be several approaches. We'll go with the most efficient approach right now. Okay, so before we jump to the solution, think of it like this. You bought it on 1. Okay, so when you are buying it on 7, you cannot sell it on at 1, right? So whenever you want to sell it, you have to make sure that the selling price is greater than the buying price. Only then there is a profit, otherwise we'll return 0. Like in this case, if you buy it at 7, there is no other price that you can sell to make a profit. Even if you buy it at 6, there is no bigger number to sell it at. For 4, 3, 1 as well. That's why the output is 0. So we have to make few things sure that when we buy a price, we can only sell it if we find a number greater than this number. Second, if suppose we did buy it at 1, next I found a number greater than 1 is 5, I can sell it and I can find out my profit is 4 rupees. But now I will check if this is the maximum profit. So every time I'll keep my buying price at 1, I next try to sell it at 3. The profit is 2 rupees. which is not greater than selling at 5, so I do not change my maximum profit. I then sell it at 6 rupees, and I know selling at 6 rupees is more profitable than selling at 5 rupees. So my overall max profit will change to 5 rupees. And similarly, if there was a number bigger than this, we'll sell it on that day. So we need to keep track of this information. Okay, let's simply do it this way. We'll initialize a min price, so minimum price, because right now we know that the minimum price is 1, but in an array we are not aware of it, so we want to keep track of it. Okay, so that we'll find a minimum price to buy it on and a maximum price to sell it on. So int min price is equal to integer dot max value. Okay, so why we are doing this, let me write it. We are initializing, so initialize min price to a large value. This is the highest integer value, so that any value that we get will be bigger than will be smaller than our earlier min price considered. So we are considering a very high value, so that we'll be able to keep track of. You can keep it 0 as well, but what if you find 0 again? Okay, or this case does not allow a negative price, it is not possible, so you can actually keep it 0 as well. There's no issue in this use case. Similarly, we'll initialize our max profit. Okay, initialize max profit to 0, because at the beginning our max profit is 0, and if we find a maximum profit, we have keep updating it. Otherwise, in the end, we return the max profit, that would be 0. Now we are going to traverse through the array. So for int I equal to 0, I is less than prices dot length. Price is coming from our prices array. Prices dot length I plus plus. Okay, now if, okay, we already considered this case, so please pay close attention. If prices I is less than min price, okay, so we have initialized min price to a very big value, and we are checking if price is I, so first number is 7, less than our min price. Of course it is less than our min price because we have initialized it with a very big number. Oh, and of course you cannot initialize this with 0. You can initialize it with 100, 200 for this use case, but the right answer is to initialize it with the maximum integer value, which is integer dot max value. So if so happens, what we will do is we'll update our minimum price. Min price equal to prices of I. Okay, so if we go through this array, when we started the traversal, we are at 7. We are checking if prices of I, which is 7, less than our min price. That is true, so we are updating our min price equal to prices of I. That means our min price has the value 7 now. So we are saying that, hey, let's buy it on 7 rupees. This was the first number, we initialized it this way. Okay, else if, so we initialized it. I'm going to write the else if condition here. This would be for the cases when the prices of I is not less than min price. Okay, but let's say when will we arrive here? Okay, so the loop covers here. We come back and I is equal to 1, so prices of I is equal to 1. Is this less than our min price? Yes, because min price is 7. So we update our min price to prices of I, which is 1. So now our min price became 1. Okay, next again I move forward because it already went to if condition, it won't go to the else part. I is equal to 2, and here we are. Okay, So prices of I, which is 5, is less than our min price? No, right? 1 is lower than 5. That means we could have bought it on 1 and now we can sell it at 5. So now what do we want to check? Now we want to check if prices. So before I write this condition, okay, I'll write this condition first and then explain. If prices of I, which is 5 in this case, minus max profit is greater than max profit. So if prices of I right now is 5 minus max profit is 0. Is it greater than our max profit? Why do we have this variable? To keep track of the maximum profit that we can generate through this array. Okay, so we bought it on 1, we finalize it with our min price. Now I'm going to sell it at 5 and we are checking if prices of I, that is 5 minus max profit 0, is greater than max profit 0. Yes, that is true. So we are going to say max profit is equal to prices of I minus min price, right? Because min price is the price at which we are buying the stock. Right now it is at 1. Max profit at this moment was still 0, and now we are saying prices of I has reached the value 5. Now max profit becomes prices of I 5 minus min price, that is 4. So our current max profit is 4. Now this loop ends here. Okay, I'll just for everyone's sake I'll update the comment section as well. Okay, update the min price so far. So if we find a price below this, we'll update this again. Update the min price so far, and here we are going to say update the max profit so far. In case a better selling day is found. Okay, now our maximum profit is 4. Whenever the loop ends, we are going to just simply say return max profit. Okay, now what happens? I plus plus and I reaches 3. Now is prices of I less than min price? Our min price is 1, this is 3. No, so it comes to else by part. If prices of I, that is 3, minus max profit, what is max profit? 4, is greater than max profit? No, right? Sorry, this cannot be max profit, this should be min price. That's how we calculate, because we bought it on min price. We are checking if I sell it at 3, so prices of I 3 minus min price 1. If I bought it here selling at 3, so 3 minus 1, is it greater than the maximum profit that I have found so far? Maximum profit is 4 right now, so no, selling at 3 will not give us any profit, so it will not enter this loop. And again I plus plus, we reaches 6. If prices of I, that is 6, less than min price? No, right? Again, else if prices of I, that is 6 minus min price 1, so I had bought it at 1. What if I sell it at 6? Is it bigger than the profit found so far? So prices of I 6 minus 1, which is 5. Is it greater than max profit, which is 4? Yes, 6 minus 1 is 5, 5 is greater than 4, so it enters this loop, and max profit is updated as prices of I, which is 6 minus min price, which is 1, 6 minus 1, and it transforms to max profit as 5. Then again I plus plus, I reaches 4. Prices of I is less than min price? No. If prices of I, that is 4 minus min price 1, 4 minus 1 3, is it greater than 5? No, so it does not enter this loop. The array completes and will return the max profit. Let's quickly run this. Okay, let's submit and check. Okay, this was, anyway, I knew this is the most efficient approach. We are solving it in O of 1, plus we are updating only the places where it is required, and we are beating 99.95% percent of the answers. Okay, that's great. Let's read the problem. Okay, that's it. So thank you everyone. This was our fourth question in our coding series. Please go through the complete series if you are preparing for your coding interviews. I'm going to cover all the questions from easy, medium, and hard, and all the 75 questions is going to be fruitful for all your interview questions, all your interviews. Thank you everyone. Please like, share, and subscribe.